Yes, you've seen it right. We are building one of the fastest databases, and I don't think there's any YouTube channel which creates these kind of videos on projects. So it's going to have 5,000 plus lines of code. Now the estimate is 10,000, but yeah, it could be more or less. But in this video, we are understanding the architecture of the project and what it is, how it works. So it's a clone of Redis, as you can see here. Now let's understand how it works, like what is Redis and what it does in the real world. Let's go. Now this is something which is about its parts, so later we'll understand them. First let's start with what actually Redis is. Now let's take an example of Netflix. Here let's let's say a user comes on Netflix app. In order to give the data to the user, we don't go to the database. Like if we go to the database, then the database takes a lot of time to return the data. Now what that makes is that makes the page load, and that keeps the user waiting on the home page. That's where Redis comes in. Now what Redis does is Redis saves the data into memory. From memory, the data comes much faster than database. That's why we use Redis. Now why database is slow? Because first it reads the disk, finds data, loads it into memory, and then returns the result. So that's too much of a process, so it takes a lot of time. But on the other hand, Redis directly it goes to RAM and stores data over there and returns it immediately. So user doesn't have to wait on the home page. Now how Redis is faster and why databases are slow. So there's no SQL parsing, no disk access, just hash lookup table and value found, send response, something like that. Now here, this is the parts of it. So first the Redis client will send something like this. Now Redis doesn't just store, like it's, have you seen dictionary of Python? It's something like this. Now you store, let me just a second. Now you store key and you store value. Okay, something like this. Now just a second, copy this down here. Okay, this is how we create a dictionary on Python, right? There's key and there's value. Now Redis doesn't just store string as value, it stores multiple things in value. For example, it stores list, and different kinds of types have different purposes. Now there is one more, that is hash, then we have set, and then we have z set. So these are the five things which Redis stores as values. Now they have different purposes, as I said, and we are going to create them all in C and in Python as well. And after that, we connect the client through TCP socket, get the data, parse it, dispatcher, we use dispatcher, then hash table. Now I'm going to provide you this Excel draw file so you can read it. Now this is too much detail. Now I've read it, but I'm not going to use detailed explanation. What we have here is different. Okay. Now we have this architecture. Now as I said, these are the parts which the Redis is going to have: the socket server, the event loop, the TCP bytes, send bytes, then it will go to RESP parser, command dispatcher, then string, list, hashes, sets, z sets, pub-sub. So publish subscriber is something which we have. Then database, LRU cache, memory manager, Redis objects. Now we're going to allocate memory. So this is about C. We are going to create this project in both the languages, that is Python and C. And the reason behind that is we are going to understand how they are going to perform in both the languages, and I think that will teach us a lot of things. Now I have this article over here. I took screenshot of it. Let's read the article. Let us start with talking about caching. In the world of computer science and software development, caching is like having a quick access memory for frequently used information. As I said, imagine you have a favorite snack that you always keep within arm's reach instead of going to the store every time you crave it. Different example now. I think it's hard to understand. So I've made my own example that is quite easy. Let's go there. Now let's say you use groceries inside your home, right? So now the first time you go to the grocery store, take the supplies, come home and store to the fridge, right? Now the next time you want it, you don't go to the grocery store again and again and again. You go to the fridge and take it. Now think, the distance between you and the grocery store must be much more than the distance between you and the fridge. Now that's why it takes more time to go to the grocery store than the fridge. Yeah, that's the reason you store it and go to the fridge and use it and take it and do that again and again. So that's what caching is. You go, this is caching and this is database. So they get like that. Let's go read forward. After that, we have, caching works in a similar way, allowing applications to keep a handy copy of frequently needed data in a special storage area known as cache. So, the main goal of caching is to speed things up instead of repeatedly going back to the original source of data, that is database, which might be slow or resource intensive. The application can fetch it from the nearby cache. This quick retrieval helps save time and resources, so that's the main purpose of it. About caching is that we cache only the data that does not change very frequently, as that we, with the purpose of not having to access a DB frequently. Okay, you may find it weird. Okay, let's move forward. Why Redis? Now that we've grasped the importance of storing data frequently, efficiently for quick access, let's tackle the question, why choose Redis as the data store for caching and not any other options like MySQL or MongoDB for that matter? The answer lies in how Redis does the job. Redis is designed specifically for speed. It's an in-memory database, storing data right in your computer's active memory, that is RAM. This makes retrieval data lightning fast because it's already in the workspace where your computer actively operates. Traditional databases like MySQL or MongoDB store data on secondary storage like a hard drive, as I said. While effective for many tasks, fetching data from secondary storage takes more time compared to fetching it from active memory. Choosing between grabbing a book from a shelf or having a cheat sheet always open on your desk. Accessing data in memory is significantly faster than performing random disks, contributing to the low latency and high throughput observed in Redis caching. Let's move forward. I hope this gives you the answer to why Redis and why this question was important. In the realm of computer memory, registers and CPU cache are the speedsters faster than RAM found within the processor. They operate as lightning speed. However, due to their high cost and limited capacity, they are like the Formula 1 racers of memory, incredibly fast but reserved for the most critical tasks. For everyday use and storing large amount of data, RAM and in-memory databases like Redis take the lead. What is Redis? Quoting the Redis docs, Redis is an open source, licensed in-memory data structure store used as a database, cache, message broker. Redis provides data structure as strings, hashes, lists, sets, sorted sets, so that is Z set, with range queries, bit arrays, hyperlogs, and streams. Redis has built-in replications, Lua scripting, LRU eviction. Now what LRU eviction means is that whenever you are not using something, it removes it automatically, or when the expiration date has come, it removes it. So something like that. Transactions and different levels of on-disk persistence. So what is that? So whenever you close the application, it saves the data which is there in cache to the disk automatically. So the data is not getting lost or something like that. Redis sentimental and automatic performing. Yeah, that's all. So I hope you understood the main work of Redis and where Redis gets used in industry and why we are building it. What's the main purpose? Now there are vast amount of things we are going to learn out of it. This is the architecture. This architecture is for C. Now for Python I have different architecture, but look how huge it is, and yeah, we are going to build it. Now in this video we are just going to build the include folder that stores all the header files which we are going to create. These files are not necessarily you need to understand, because first we have to write the C code, but what happens is we have to understand the C code, then you'll understand this directly. But we are going to write this code first. Like I'm just going to copy, not write, because it will take a lot of time, and then by the time we'll write C code, the actual functions which I've declared here, then you understand every struct, every enum which we are going to create. So you don't have to worry about not understanding this right now. So let me just create the include folder here, and the first file which we are going to create, let's go to my Obsidian vault. I've mentioned every architecture here, like every file and what it's going to have and everything, libraries. So let's just code by without copying. Let me just create this file which is common.h. Now what is common.h going to have. We can't always import, like we'll need this much libraries in every file. Now we can't just import this much libraries in every file, right? So that's why we are importing them into one common.h file, and then we'll include this common.h file into every file. And so it just makes it a lot simpler. Let's include standard int, include standard int, then we have include standard def, then we have IO library. Okay, then we have library, include standard lib.h, then we have string error no time, okay, sorry string error no, and then we have time, then we have assert, and then we have one more thing, that is limits. Okay, yeah, perfect. So we have included all the files, but before that let's just let me just a second. So if not, define common edge, and then we have to define it edge. Perfect. Now here let me just add endef, and perfect, right? Now the next, now we have to define some constants which we'll need later while building the logic itself. So we have Redis version. Now I'm going to copy these, okay? I have got them. So there you go. Now these are the defined constants which I've defined. Now the first one is Redis version, just so that we know which version it is in every file, and it will be common. And then we have default port, which is Redis also use this port, that is 6379. So yeah, we are going to use that. Maximum key size, so how much key size is going to have, so it's 512 characters. Then we have maximum value size, okay, that's going to be 1 MB. Then we have hash load factor, which is 0.75%. Then we have 75%. Now, as I said earlier, you don't need to understand these constants which I have defined, because while building the logic, we'll use them, right? So it's not like we are going to miss them. It just we are declaring them earlier, so later we don't have to declare them in every file. So these are the concepts which we are going to use in a lot of files later and build logic with them. So yeah, you just have to just go through them. That's what I have to say. Then we have maximum clients, which are going to be 1024. Then buffer size 1096. Then again, how much buffer you can send, that is 1096. Arena default size could be 1 MB, and the default buffer size, that is 64. Inline buffer size, that is 64. Now there are a lot of things which are going to be there, that is type defs. Let me just write that myself. Okay, now uh, type, okay, type defs. Okay, now what we have, type def, the first one which we have is u8. So int 8, and it's going to be u8. Let me just copy it, like it will take a lot of time for me to write all the include files. So let me copy every file, then we'll understand them. Okay, so now I've copied all the code from all the files, so we have everything here. Now this is enum. So the last time we were building this, so I've just defined some unsigned integers here, like every byte. We can't use int because every system has different size of int, so we can't rely on that. That's why we have here, we've predefined everything. So this is the one which we are going to use, and instead of writing this huge strings everywhere, we are going to just write this small amount of things, so we'll also understand them. Now I've defined enum. Okay, now what this does is it just represents the type of data we are storing, that is string, list, hash, set, and set, as I've already said in the intro. Then we have again some errors. Now I have explained everything to you in comments. As you can see here, you can read it. So by the time you'll get the video, there will be the GitHub link in the description with the code which I have explained to you in this, not explained, but I've just shown you to you in this video, so you can read it in detail and understand everything if you want. But I'd say that it would be a lot easier to or understand them later while building the logic. So these are all the errors which I have declared. Then we have the status of connection, whether it's disconnected, connected, connecting, reading, so on and so forth. Now I've also defined some macros here. Now this gives us minimum value, maximum, array size, so align up, unused, and then we have some other macros. So you need to have at least basic knowledge of these things. So all the .h files gets executed by preprocessor, which runs before compiler. Now you need to understand the code doesn't directly go to the compiler. So what happens is it goes to preprocessor first and then it goes to compiler. Now there are steps to it which even I don't know, to be honest, but yeah, I just know these things, which are enough, I think. Then we have allocator here. Let's see what I've did in allocator. Now we have a struct arena. So this is where now we are not going to call malloc every time we need a memory. So we are just going to get a huge amount of memory, like a huge block, and then we are going to divide that block and give that as needed. Okay, so we don't have to call malloc every time. Then we have free block, pool allocator, and a lot of things and functions. I've declared some functions as well. Then we have commands. So in that we have command struct and some functions. Then we have database. Here also I have database struct. Then some functions. Then we have hash. I've declared some enums. Whether the whether the slot is empty, occupied, or tombstone. What does tombstone means? Now tombstone means the slot wasn't empty. There was value before, but now it's gone or it's deleted. So that's when we declare it as tombstone. Then we have again hash entry, hash table, and yeah. So the next thing which we have is list. Now here also I have declared a struct called list node, and then we have list and some functions again. Okay, here also I have one enum, again declaring the type we are going to use. Then redis object, and yeah, then some functions. Then we have protocol here, again some enums and a RESP parser struct. Now as you can see here, now that I wasn't fooling you. Okay, all the things I have mentioned here in my obsidian vault that we are going to have RESP no, not here actually, yeah, over here. As you can see, we are going to, I said we are going to have all these things, and we do have all those things. Hash table, LRU, cache, memory manager, redis objects, allocated memories. We do have all those things, okay? And then some functions. And then we have skip list here, skip node, and skip list struct, and then some functions. Now we have completed this architecture. Now these columns 1 and 2, now these columns are remaining, which we are going to build episode wise. Now we have to build src folder, then we have protocol folder, then we have commands folder, then we have pubsub, which I said earlier, then we have utils, then we have test, we also have here something, we have memory, then we have persistence. So a lot of things. And yeah, we are going to build this now. As I said, it's going to have thousands of lines of code, so it is going to be production ready. It's going to follow industry standards and everything. So yeah,